AI will revolutionize computing everywhere, from scientific computing, cloud, enterprise data centers, edge, to autonomous machines. We've created the AI system to write the software and the robotics computer to run it. And with NVIDIA Omniverse, we have a physically based simulation engine to create the worlds to train the robots. Omniverse is NVIDIA's platform for simulation and collaboration. The NVIDIA Clara Discovery, a state-of-the-art suite of tools for scientists to discover life-saving drugs. Where no tools exist, we develop them, like the NVIDIA Parabricks, Clara Imaging, BioMegatron, BioBERT, and NVIDIA Rapids. We built a ready-made AI supercomputer called the NVIDIA DGX SuperPod, scalable from 20 to 140 DGX systems. The Bluefield DPU is a data center infrastructure on a chip. Bluefield 2 has ARM CPUs and a whole host of state-of-the-art accelerators and hardware engines. Today we're announcing DOCA, a programmable data center infrastructure processor architecture. NVIDIA AI inference compute is growing 10 times every couple of years, and this year surpassed total CPU compute in the cloud. We've reached a tipping point of accelerated AI inference. Every AI service and application can now be GPU accelerated. NVIDIA Jarvis, our state-of-the-art conversational AI application, is now in open beta. Today, we're announcing NVIDIA Maxine, a cloud-native streaming video AI platform for applications like video calls. We're announcing a major initiative to advance the ARM platform. Today, we are thrilled to announce a major partnership with VMware. Together, we're porting VMware onto Bluefield. Our partnership will redefine the data center. And we announced that Cloudera is accelerating with NVIDIA AI. The final piece, the enabling technology of IoT, is AI. This is the NVIDIA EGX Edge AI platform. NVIDIA EGX is designed to make it easy for the world's enterprises to quickly stand up a state-of-the-art Edge AI server. We're announcing that the Jetson Nano 2 GB will be $59. Anyone can now build a robot. The age of AI has begun, and NVIDIA is in full throttle to advance this new form of computing.
I am an explorer. Searching for the origins of our universe. And charting a safer path to other worlds. I am a helper, moving us forward one step at a time, and giving voice to every emotion.
I love you.
I am a healer, modeling the future of medicine. Finding a needle in a haystack when every second counts. I am a visionary, uncovering masterpieces lost to the ages. And finding new adventures in a galaxy far, far away. I am a builder, driving perfection in everything we create. I am even the narrator of of the story you are watching. And the composer of the music. And when the world faces its greatest challenge, I give us the power to take it on together.
Welcome to GTC. This is one of the biggest ones ever. Over 1,000 sessions, 400 more than last GTC. This is the first GTC that will run across the world's time zones, with sessions in Chinese, Korean, Japanese, and Hebrew, all in local times. I would like to thank all the speakers and sponsoring partners for helping us make this a great GTC. This is an amazing time for the computer industry and the world. As mobile cloud matures, the age of AI is beginning. Why is AI so important? Why is it the most powerful technology force of our time? Computing is the technology of automation. Software algorithms automate. Automation drives productivity and growth for industries. For example, farming automated food production and revolutionized society. Automation lowers costs for consumers and make life more convenient. Automatic electricity and water improved our quality of life. Automation at large scales lead to breakthroughs, just as search has automated getting information and getting answers. There are many things we like to automate. We're limited by our ability to write the software. Finally, after decades of research, deep learning, the abundance of data, the powerful computation of GPUs came together in a big bang of modern AI. Now software can write software. So AI is the automation of automation. Incredible implications. Let's explore some of it today. The software written by AI is very different than that written by a human. It is vastly more parallel and thousands to millions of times more compute intensive. The method of developing the software is different. The computing infrastructure is different. The tools are different. The software runs differently, and even the method of deployment is different. AI requires a whole reinvention of computing. Full stack rethinking, from chips to systems, algorithms, tools, the ecosystem. NVIDIA is a full stack computing company. We love working on extremely hard computing problems that have great impact on the world. This is right in our wheelhouse. We're all in to advance and democratize this new form of computing for the age of AI. NVIDIA is dedicated to advancing accelerated computing. Enabling developer success on our platform is core to everything we do. GTC is all about developers. Developers adopt a new platform only if it solves a problem 10 times better, and that has a large and growing installed base. And developers need great tools. Domain after domain, graphics, high-performance computing, data science and analytics, artificial intelligence, healthcare, self-driving cars, robotics, to the 5G edge, NVIDIA created platform SDKs to make it easier for developers to tap into the power of NVIDIA computing and make it easy to deploy your software on NVIDIA computers in every cloud and any data center and edge. This GTC, we're releasing 80 new and updated SDKs. There are now a total of 110 SDKs. Developers need an architecturally compatible and significant installed base. NVIDIA has shipped over 1 billion CUDA-compatible GPUs. CUDA SDK has been downloaded 20 million times, and 6 million times this year alone. It is clearly accelerating. 1,800 applications are now CUDA accelerated. There are 6,500 startups building on NVIDIA. The top developer SDKs include NVIDIA AI, NVIDIA RTX, NVIDIA Rapids for data science, and NVIDIA Isaac and Drive for robotics and autonomous machines. There are over 2 million NVIDIA developers now. 600,000 joined this last year. To all, a big welcome. Let's start with graphics. At its core, computer graphics is about simulating the physics of light and matter to simulate reality. Simulating reality is a great computer science challenge and computationally unbounded. This is the driving force of our company. 20 years ago, NVIDIA introduced the programmable shading GPU. The GPU revolutionized computer graphics. Hundreds of millions of insatiable gamers made the GPU the most advanced chip in the world. NVIDIA GPU processing has increased a stunning 100,000-fold. We recently launched Ampere. It is the greatest generational leap ever. We expected and prepared for huge demand, and the response was still staggering. I know many of you are anxiously waiting for your new Ampere GPU. It's totally understandable, and I assure you that it's worth the wait. Ampere is the fastest ramp in our history. Everything we ship is instantly sold out. We're working around the clock. Your new GPU is coming. You're going to love the new Ampere GPU. Ampere is the second generation NVIDIA RTX, fusing programmable shading, ray tracing, and artificial intelligence, giving us photorealistic graphics and the highest frame rates at the same time. Once the holy grail of computer graphics, ray tracing can now be standard. If the last 20 years was amazing, the next 20 will seem nothing short of science fiction. The metaverse is coming. Metaverse was first coined by Neil Stephenson in his 1992 science fiction novel Snow Crash. Humans as avatars and software agents interact in a 3D space, a virtual reality successor to the internet. With worlds like Minecraft and Fortnite, we're already seeing the beginnings of the metaverse. Though they seem like games today, gamer inhabitants of these early metaverses are building cities, gathering for concerts and events, and connecting with friends. Future worlds will be photorealistic, obey the laws of physics or not, and inhabited by human avatars and AI beings. The metaverse is not only a place to game. We will create the future in these metaverses before actually downloading the blueprints to be fabbed in the physical world. Omniverse is NVIDIA's platform for simulation and collaboration. Omniverse is built from the ground up for the future. Cloud native, multi-GPU, photorealistic with path tracing and material simulation, and physically based, obeying the laws of physics. Omniverse is designed to connect to many worlds. Worlds like Epic's Unreal, Maya, Blender, Adobe, Autodesk, and others. Omniverse allows designers, artists, creators, and even AIs using different tools in different worlds to connect in a common world, to collaborate, to create a world together. Omniverse is even a world where AI agents are created and learn, a simulator for robots. In Omniverse, everything is physically simulated. It's a place where robots can learn how to be robots, just like they would in the real world. Ladies and gentlemen, NVIDIA Omniverse, an open platform for collaboration and simulation. NVIDIA Omniverse is in open beta now. Understanding disease is one of the great human endeavors and remains an incredible challenge. Drug discovery is hard. On average, taking over a decade to develop, $2.5 billion in R&D, and yet 90% of the efforts fail. The cost has doubled every 9 years. This is called Ehrum's Law. For the $1.5 trillion pharma industry, there's a great deal at stake to accelerate the successful discovery of new drugs. COVID-19 hits home this urgency. Using breakthroughs in computer science, we can begin to use simulation in silico methods to understand the biological machinery of the proteins that affect disease and search for lead candidate drugs before the slow process of in vivo testing. Drug discovery is hard in every respect. First, it is hard to find the protein that is implicated in a disease. Second, it is hard to find a small molecule, chemical compound that can bind with and to activate or deactivate the protein. Third, getting the small molecule inside the cell is hard, as Mother Nature has created defense systems to protect us from foreign substance. Finally, what does your body do with a chemical compound? How does it safely absorb, distribute, metabolize, and excrete the compound? This is called pharmacokinetics. A spectacular arsenal of technologies is deployed in drug discovery. Genomics is used to choose protein targets responsible for a disease and determine which patient will respond to a drug. Cryo-electron microscope imaging and 3D reconstruction let us see a protein structure which determines its function. Data analytics is used to screen 10 to the 60th potential chemical compounds for fingerprints that might lead to a drug candidate. Deep learning AI is used to generate and design new leads learning from known chemicals. Docking predicts affinity, the strength of the bond between a chemical and a target protein. Molecular dynamics analyzes the physical motion of a protein and its interactions with a chemical. Pathology and radiology imaging are used to study the biomarkers, the condition of a disease and effectiveness of a drug. Natural language processing study publications and health records to find chemicals that might be repurposed for other disease targets. Today, I'm pleased to announce the NVIDIA Clara Discovery, a state-of-the-art suite of tools for scientists to discover life-saving drugs. Where there are popular industry tools, our computer scientists accelerate them. Where no tools exist, we develop them, like the NVIDIA Parabricks, Clara Imaging, BioMegatron, BioBERT, and NVIDIA Rapids. We hope this will bend the trajectory of Ehrum's Law and lead to faster and more effective discovery of life-saving drugs. The UK is an epicenter of healthcare research. In fact, Cambridge is the home where Francis Crick and James Watson discovered DNA. But scientists in the UK need a state-of-the-art computing infrastructure. So we're going to build one. It's called Cambridge One. 400 petaflops of AI performance. It will be the fastest in the UK and top 30 in the world. Cambridge One will host our UK AI and healthcare research collaborations with academia, industry, and startups. All partners already use NVIDIA computing. Cambridge One lets them do experiments too large for their infrastructure or while theirs are being built. Our first partners are AstraZeneca, GSK, King's College, NHS, and Oxford Nanopore. Today, we're also announcing a partnership of GSK and NVIDIA to build the world's first AI drug discovery lab. Let's hear from Dr. Kim Branson, GSK's head of AI.
Understanding human disease has never been more urgent or important than it is today. This undertaking is bringing together the best minds and the latest breakthroughs in biology. The complexity of human biology is striking. There are 45,000 genes that make up 500 million protein interactions in a single cell alone, and the human body has trillions. With new tools, including genomic sequences, microscopy, and medical imaging, we can measure this complexity for the first time, from a genome to a single cell to a protein. And new perspectives, looking at population-scale data, now capture the vast diversity of human health while helping us zoom in on an individual's unique genetic makeup and personal history. GSK has accumulated more data in its first quarter this year than in its entire 300-year history combined. It's an amount of data no human could understand and no equation can fully capture. So GSK believes that AI and computational biology, especially when combined with our vast data sources, can break new ground in drug discovery. But we can't do it alone. That's why GSK is partnering with NVIDIA to build out the world's first dedicated in-house drug discovery AI lab.
If AI is software written by a computer, then companies will need powerful AI computers to write great software. This insight has transformed NVIDIA and other AI leaders. I expect every major industry, healthcare, transportation, manufacturing, logistics, retail, will all eventually have large AI compute infrastructures that collaborate with their software developers and researchers. But it is challenging to build these systems, to develop the software, and the tools to run on these large supercomputers. So we built a ready-made AI supercomputer called the NVIDIA DGX SuperPod. The DGX SuperPod is available now, scalable from 20 to 140 DGX systems. A 140 DGX configuration is a top 20 supercomputer in the world. We've also published a SuperPod blueprint for our large network of partners to replicate using NVIDIA technologies. Enterprises can go from zero to their valuable AI researchers being productive in just a few weeks, not many months. The savings and productivity alone will pay for the system. You've heard me say it, the more you buy, the more you save. There are many installations going around the world already. CDAC is going to be the most powerful AI supercomputer in India. Argonne National Lab is using DGX SuperPod for computational drug screening. The University of Florida has a system built to train next-generation AI researchers and students. The Wallenberg AI and Software Research is building the largest AI infrastructure in Sweden. Facebook AI Research Lab has Super DGX for their researchers. And Naver, Korea's #1 search engine and world's fastest growing messenger platform, is installing SuperPod to advance natural language understanding. AI is writing software that achieves results no human-written software can. The scalability of this approach has started a race to create ever larger, more complex, and more capable AI. The chart shows the number of days to train a model on a 1 petaflops computer. Computation required to train state-of-the-art models has increased 30,000 times in less than 5 years. That's doubling every couple of months. The capabilities of AI are incredible. NVIDIA's natural language understanding AI took the race reading comprehension test consisting of 30,000 passages and 100,000 multiple choice questions. The average human scored 73%. Expert humans scored 95%. NVIDIA's Megatron BERT scored 91%. Facebook AI Research developed a transformer-based chatbot with knowledge, personality, and empathy that half of the users tested actually preferred. Researchers at Caltech developed a reinforcement learning-based drone flight control system that flies smoothly through turbulence and changes in terrain. Other researchers at Caltech use deep learning and quantum chemistry to predict molecular protein reaction energy, sped up simulation by 1,000 times. TUM, Technical University of Munich, Google, NVIDIA, and Oak Ridge National Lab trained language models that predicted the 3D structure of a protein just by reading its amino acid sequence. The 3D shape is used to predict whether a chemical compound would bond to the protein. Researchers at NVIDIA use deep reinforcement learning to train the control system of a 4-legged robot to adapt its gait across multiple terrains, even if the surface is in motion. The progress of AI is incredible and like magic. The magic of AI also comes with its incredible computing challenges. Enormous models and training data sets that push the limits of every aspect of the computer: compute, storage, networking. NVIDIA is democratizing AI. There are 3 pillars to NVIDIA AI. First, data processing, feature engineering, and training at any scale. 1 GPU, multi-GPU to multi-node, any framework, any model, in any cloud. Second, inference is a great computing challenge. NVIDIA TensorRT is a graph optimizing compiler that targets an NVIDIA inference computer while optimizing for a bunch of competing constraints: accuracy, throughput, response time, memory size. We're releasing TensorRT 7.2, over 2,000 kernel and layer type optimizations. TensorRT has been downloaded 1.3 million times, used by 16,000 companies, operating over 300 services around the world today. NVIDIA Triton Inference Server is used by data centers to deploy AI models. NVIDIA Transfer Learning Tool lets customers take pre-trained models and refine them for their own data sets to optimize for their usage domain, like refining a general language model for healthcare or engineering speak. Third, AI application frameworks, pre-trained models, transfer learning, runtime engines for some of the most challenging AI applications, like self-driving cars, robotics, drug discovery, conversational AI, and recommender systems. Thousands of NVIDIA engineers are working on NVIDIA AI today, and thousands of companies around the world run on NVIDIA AI. The software stack for AI and accelerated computing is complex. The stacks for each domain are different. Rendering is different than genomics, different than data analytics, and different than deep learning. The stacks for each computing environment, virtualized or scale-out or microservices, are also different. NGC is our cloud for containerized stacks. Always up to date, always optimized, NGC runs on all NVIDIA certified OEM systems and clouds. NGC has been a huge success. 1 million downloads in just a couple of years, 250,000 users, growing 4 times year over year. Cloud service providers have asked us to integrate NGC into their clouds. So today we're announcing that NGC will also be available in Azure, AWS, and GCP marketplaces. NGC will be easily discoverable in CSP clouds and always up to date with the master registry. With this, you can be assured to get the best performance and the lowest cloud compute cost. And your cloud and on-prem stacks will be consistent. Engineering is required, so we'll get there as fast as we can. In the meantime, the optimized stacks are on NGC. Billions of people are interacting with cloud services, hundreds to thousands of times each day. Each interaction launches a query, a recommendation, an ad, a piece of news, and often all of the above. Trillions of AI services are processed each day. Processing the AI on NVIDIA is the most performant and cost-effective. This year is the 10th anniversary of the first NVIDIA GPU in the AWS cloud. Since AWS, every cloud now offers NVIDIA GPU, and the aggregate compute throughput has increased 10x every 2 years. This year, we will ship over 166 exaops of inference compute to CSPs, more than 6x that we shipped last year. We estimate that the aggregate NVIDIA GPU inference compute in the cloud now exceeds that of all cloud CPUs. With this trend, in a couple of 2-3 years, NVIDIA GPUs will represent 90% of the total cloud inference compute. Any AI application and service can now rely on NVIDIA inference. We are past the tipping point. NVIDIA AI Inference is operating services for companies in a broad range of industries, from cloud, financial and consumer services, autonomous vehicles, robotics, healthcare, agriculture, and retail. Take, for example, Square. They're using NVIDIA to process conversational AI for businesses to schedule appointments with customers. Twitter is using NVIDIA AI to understand the torrent of live videos. eBay does millions of item image searches a day with NVIDIA AI. GE Healthcare uses NVIDIA AI to infer measurements on cardiovascular ultrasound. Zoox, the robot taxi group of Amazon, uses NVIDIA AI to do perception for cameras, lidars, and radars. Today, we're announcing that Microsoft is adopting NVIDIA AI on Azure to power smart experiences in Microsoft Office, the world's most popular productivity application used by hundreds of millions will now be AI-assisted. The first features will include smart grammar correction, Q&A, text prediction. Because of the volume of users and the instant response needed for a good experience, Office will be connected to NVIDIA GPUs in Azure. With NVIDIA GPUs, responses take less than 200 milliseconds, and our throughput lets Microsoft scale to millions of simultaneous users. The inference pipeline consists of NVIDIA V100 in Azure running the Onyx runtime on NVIDIA Triton Inference Server. Cybercrime costs the global economy nearly $1 trillion a year, about 1% of the $140 trillion global economy. American Express does 8 billion transactions a year, totaling $1 trillion for their 115 million cardholders. Huge numbers. Using NVIDIA AI, American Express processes tens of millions of transactions daily, each within 2 milliseconds, to detect fraud instantly. AI fraud detection is going to save the financial industry hundreds of billions each year. NVIDIA AI makes this possible. Modern cloud services are composed of microservice containers and orchestrated by Kubernetes. Microservices like automatic speech recognition, natural language understanding, text-to-speech, recommenders, database queries are reused by many applications all at the same time. These microservices are running on servers throughout the data center and scaled up and down to meet dynamic workloads while delivering good response time. Modern data centers are scalable, composable, and accelerated with servers of different types, like CPU, GPU, and storage, each optimal for certain types of microservices. Let me show you one of the most advanced AI applications running end-to-end. All of the technology components are state-of-the-art and ready for you to customize and deploy in the cloud or on-prem. This is Speech Squad, a benchmark we developed to measure the response and throughput of conversational AI. Speech Squad asks a question, understands the question, searches for the correct answer, and generates a natural human voice response. It consists of speech recognition, Q&A using BERT, and text-to-speech. Speech Squad is open sourced on GitHub. First, let's run Speech Squad on a CPU.
When did the Germanic tribes claim territory in North and West Europe?
In the middle period of classical antiquity.
Each of the ASR, BERT, and TTS services are assigned to its own CPU. The response time is over 600 milliseconds. CSPs want response time in about 300 milliseconds. For a CPU, that's not enough time to use a neural network model. So we're using CalD for speech recognition and MaryTTS for speaking. That's why CPU sounds mechanical. Now let's run Speech Squad on Jarvis on GPU.
What is the highest court in European Union law?
The European Court of Justice.
Again, we assign each of the ASR, BERT, and TTS microservices to GPUs. The latency is now 300 milliseconds, twice as fast as a CPU. And GPU can deliver a much more human quality speech. We're using NVIDIA Tacotron speech synthesis and NVIDIA WaveGlow voice encoding, 100 times more computationally intensive than CalD and MaryTTS. However, it sounds a lot more natural. Let's scale the service to support 1,000 streams. NVIDIA Triton scales up 15 A100s. Notice we're getting super linear scaling. This is because the Triton inference server is doing load balancing of the microservices. It takes over 100 CPU nodes to support 1,000 streams. Scaling to 112 A100s deliver nearly 7,200 streams. This would require 1,000 CPUs. So with A100, conversational AI is half the latency, a third the cost, and much more natural sounding. What did I tell you? The more you buy, the more you save. I want to thank GCP for letting us run the experiment on their cloud A100s and CPUs. GCP is a fabulous cloud infrastructure. NVIDIA Jarvis, our state-of-the-art conversational AI application, is now in open beta. Jarvis is an AI with conversational skills and trainable only with large AI infrastructures like DGX SuperPod. Its neural text-to-speech is human-like. Its natural language understanding is our reading comprehension record-setting Megatron BERT, and the application is fully customizable. Live video calls are one of the highest traffic on the internet today. For work, social, school, virtual events, doctor visits, video conferencing is now the most important application for many people. Today, we're announcing NVIDIA Maxine, a cloud-native streaming video AI platform for applications like video calls. AI can do magic for video calls. Using AI, we can perceive the important features of a face, send only the changes of the features, and reanimate your face at the receiver. This reduces bandwidth by a factor of 10. AI can reorient your face, so you're making eye contact with each person on the call, individually. Your face is regenerated to make eye contact with each person. AI can realistically animate an avatar based on just the words you're speaking.
Yes, there was recently a sign of extraterrestrial life on Venus. What else do you want to know?
AI can remove background noise, super res, see better in low light, replace your background, and even relight your face. And with Jarvis Conversational AI, we can do real-time language translation and closed captioning. One person is heard, but everyone can simultaneously talk. What they say is closed captioned or texted. With Jarvis and Maxine, we have an opportunity to revolutionize video conferencing of today and invent the virtual presence of tomorrow. NVIDIA AI inference applications are coming from every industry. Natural language understanding, Microsoft Office, instantaneous fraud detection, conversational AI, AI video calls, robotics. NVIDIA AI inference is in every cloud, growing at 10 times every couple of years, and have even eclipsed the total inference compute of CPUs in the cloud. We've reached a tipping point of accelerated AI inference. Every AI service and application can now be GPU accelerated. Data center is the new unit of computing. Modern data center workloads are diverse and not limited to monolithic applications running on single nodes. AI and data analytics applications are distributed, running on multi-GPU and multi-node. Cloud services are disaggregated and composed of microservices. These new workloads put tremendous pressure on the network. East-west traffic has skyrocketed. NVIDIA created the Magnum I/O SDK to offload moving data from the CPU with Mellanox RDMA and accelerate the networking, storage, and security processing on Mellanox NICs. Magnum I/O SDK includes acceleration for each computing domain. Modern data centers are also software-defined. The compute virtualization trend that enable easier resource pooling and management has now extended to networking, storage, and security. What used to be dedicated hardware appliances are now software services running on CPUs. The entire data center is software programmable and can be provisioned as a service. Virtual machines send packets across virtual switches and virtual routers. Perimeter firewalls are virtualized and can protect every node. Microsegmentation secure east-west communications, so attackers can't move laterally across the data center. The software-defined data center is great for manageability, scalability, and security. But all the data center infrastructure processing and software is a huge tax on CPUs. As more users load the hyperscalers, each microservice comes with it the associated virtualization, networking, storage, and security processing, all of it consuming CPU resources. A new type of processor is needed that is designed for data movement and security processing. We call it the data processing unit. The DPU consists of accelerators for networking, storage, and security, and programmable ARM CPUs to offload the hypervisor. The DPU is a data center infrastructure processing chip. It is estimated at least 30% of the CPU cores can be consumed running the data center infrastructure. Today, we're announcing the Bluefield 2 DPU. It is a programmable processor with accelerators and engines for at-line speed processing for networking, storage, and security. The Bluefield DPU is a data center infrastructure on a chip. Bluefield 2 has ARM CPUs and a whole host of state-of-the-art accelerators and hardware engines. Bluefield 2 does the security processing for private, public, and hybrid clouds. The Bluefield air-gaps the application domain from the infrastructure domain, stores and accelerates encryption keys, does SH-256 authentication and encryption protocol processing. It does regular expression and deep packet inspection processing for app recognition, intrusion protection, web application firewall, and out-of-band malware detection. Bluefield 2 includes traffic rate controlled packet pacing for video streaming, SMPTE 2110 broadcast, and 5G networks. Bluefield 2 is also an amazing NVMe storage processor. It's great for both compute as well as the storage server. It does elastic block storage encryption, dedupe, and compression. These are some of the examples of advanced functions that Bluefield 2 offloads from the CPU and accelerates. If done in software, the IPsec, regular expression processing, packet pacing, elastic storage would consume some 125 CPU cores to run at 100 gigabits per second. And of course, BlueField 2 is amazing at high-performance networking. It has the industry's best RDMA, ASAP2, accelerated switching and packet processing, software-defined network acceleration for OpenStack and Kubernetes. BlueField 2 is a 7 billion transistor marvel, a programmable data center on a chip, one that we intend to support for as long as we shall live, just like CUDA. Today we're announcing DOCA, a programmable data center infrastructure processor architecture. DOCA SDK lets developers write infrastructure apps for software-defined networking, software-defined storage, cybersecurity, telemetry, and in-network computing applications yet to be invented. DOCA is built on open APIs, such as P4 for packet processing, DPDK for networking, SPDK for storage, and CUDA and NVIDIA AI. DOCA is fully compatible and seamlessly integrates into all major OS and hypervisors. Applications written for DOCA will run on BlueField 2 and all future versions of BlueField. Today, we are thrilled to announce a major partnership with VMware. VMware runs the world's enterprise. They're the OS platform in 70% of the world's companies. VMware pioneered the virtualized enterprise and now driving the software-defined data center revolution. Together, we're porting VMware onto BlueField. BlueField is a data center infrastructure processor, and VMware is the data center infrastructure OS. Our partnership will redefine the data center. We will offload virtualization, networking, storage, and security onto the BlueField and enable distributed zero-trust security. Our work will give 30 to 40 million enterprise servers around the world a big boost in performance and security. Let me show you the benefits of offloading, accelerating, and isolating with BlueField. This demo is Volvo's actual design environment. A lot of technology is involved here. This is a direct visualization from Volvo's PLM actual car CAD data. IP protection and security is paramount. The amount of data being retrieved, streamed, and loaded to render is incredible. Remember, this is the entire car. This is the original CAD data of the car. Security, storage, and networking is done on BlueField. Omniverse on RTX GPU is doing the photorealistic path tracing. VMware is doing the virtualization, software-defined data center stacks, and virtual workstation. The left is BlueField, and the right is a server running the entire stack on CPU. With VMware on BlueField, the networking, storage, and security processing is offloaded, accelerated, and isolated. Both systems are experiencing DDoS attack. The designer on BlueField 2 server carry on while those on CPU servers are throttled as the CPU fights hard to block the intruder. We now have the pieces together for a programmable data center infrastructure platform. The BlueField 2 DPU, the DOCA SDK, and the VMware OS platform. BlueField 2 is just the start. Our DPU roadmap is in full throttle. BlueField 2 is sampling, BlueField 3 is finishing, and BlueField 4 is in high gear. And BlueField 4 adds CUDA and NVIDIA AI, turbocharging the in-network computing vision. Every BlueField is compatible. One architecture, DOCA. Today, we're also announcing the BlueField 2X, adding an Ampere GPU to BlueField 2 to do the in-network computing with CUDA and NVIDIA AI. State-of-the-art security functionality can now be done in software, like anomaly detection, traffic analytics at line rate, host introspection to identify malicious activity, dynamic security orchestration, online video analytics. BlueField 2X is like having a BlueField 4 today. We're going to bring a ton of technology to networking. In just a couple of years, we'll span nearly 1,000 times in compute throughput and delivering data rates ranging from 200 gigabits to 400 gigabits. This is super exciting, the beginning of the programmable data center infrastructure. The world's enterprise is awakening to the power of AI. What AI and machine learning application would the world's enterprises need? How will today's enterprise computing environment accommodate the new model of computing scale out, and microservices. For the rest of my talk, I will explore some of these. One of the most important AI models is the recommender. It is the engine of e-commerce, digital ads, social media, news readers, music and movie services, user-generated content platforms, and even search. Learning from data, a recommender will learn your explicit and implicit preferences to recommend the trillions of physical and digital items in the world to billions of people. Recommenders are extreme data processing and machine learning systems. Large-scale services can be collecting petabytes of data a day from interacting with hundreds of millions of users and connecting them to the continuous stream of new news, new video, and new goods. Data engineering teams process the data into data frames. Data scientists engineer from structured data or using deep learning to learn features from unstructured data that may be predictive of your preferences. The ML ops teams deploy the models at scale. New model generates new interactions that will be used to update the model. Meanwhile, new features are being engineered and new AI models are being explored. The more predictive, the greater the click-through rate. A 1% improvement in accuracy can translate to billions more sales or better customer retention. The recommender system consumes entire data centers. Iteration loops can be weeks. Companies understandably want it to be hours. NVIDIA Merlin is the first end-to-end accelerated recommender system ever created. Merlin is super fast and scalable. Scalable to as large as you like. It is plumbed from data load to training to inference. And with version 0.2, we can load data directly from AWS, GCP, Azure, and Apache Hadoop file system. We've gotten great feedback on Merlin. Tencent used Merlin to train a recommender for their video platform. Their cycle time went from a day to 3 hours. The increased cycles of learning allowed them to increase their model accuracy. Merlin is now in open beta. The core engine of Merlin is NVIDIA Rapids and is fast and scalable. Rapids is the fastest ETL engine on the planet, and it supports multi-GPU and multi-node. Its API is modeled after Pandas, XGBoost, and Scikit-learn, the hugely popular data science frameworks. So Rapids is easy to pick up. On the industry standard data processing benchmark, running 30 complex database queries on a 10 terabyte dataset, a 16 DGX cluster ran 20 times faster than the fastest CPU server and is 1/7 the cost and 1/3 the power. Rapids has been downloaded nearly 500,000 times, with this year nearly 3 times the download over last year. Adobe is using Rapids as the data engine for their intelligent marketing service. Capital One is using Rapids for their critical business operations like fraud detection and chatbot. Data processing is foundational to all enterprises in the data-driven era. While some companies are just starting to use deep learning, nearly every company is doing data processing with exponentially growing scale. Industry-leading data science and machine learning platforms and cloud services are integrating Rapids. Cloudera is a leading enterprise data analytics software company. Their platform runs on over 400,000 data center CPU nodes. Over 2,000 enterprise customers use Cloudera globally. They serve 8 of the top 10 financial services companies, all 10 of the top 10 telcos, and all 10 of the top 10 healthcare institutions globally. Cloudera is a hybrid cloud data platform that lets you manage, secure, analyze, and learn predictive models from your data, the entire life cycle of your data. Today, we're announcing Cloudera will accelerate their data platform with NVIDIA Rapids, NVIDIA AI, and NVIDIA Accelerated Spark. It will be called Cloudera Data Platform, powered by NVIDIA. Several thousand engineering years of work will instantly be available to their over 2,000 enterprise customers. Notice the lower right box of the Cloudera Data Platform, the private cloud. There are 2 types of computing environments, bare metal for scale out and virtualized multi-tenant. Bare metal is essential to achieve multi-GPU, multi-node scale out, needed for large data processing or training. Scale out and virtualized computing cannot share one infrastructure today. This creates 2 distinct infrastructures that are managed and operated differently, not shareable, and more difficult to secure. There is a solution. NVIDIA and VMware are announcing a second partnership. We are going to do some serious computer science to create a data center platform that can support GPU acceleration for all three major domains of computing today: virtualized, distributed scale-out, and composable microservices, all NVIDIA accelerated. Enterprises running VMware will be able to enjoy NVIDIA GPU and AI computing in any computing mode. This is a massively exciting project, and every bit as exciting as when VMware first virtualized the data center. VMware and NVIDIA are going to bring AI to the world's enterprises. Everything that moves will be autonomous someday, whether partially or fully. Breakthroughs in AI software has made all kinds of robots possible, and we're working with companies and enthusiasts all over the world to build these amazing machines. Ones that fly, walk, or swim, with 2, 4, or more wheels, underwater or in space, to deliver pizza, move inventory, farm lettuce and strawberries, or just being a helping hand. AI software was the big breakthrough, but it is the Jetson AI computer that is democratizing robotics. Jetson is a robotics computer. It's mighty, yet tiny, energy efficient, and affordable. Jetson is an ARM SoC that is designed from the ground up for robotics. The sensor processors, the CUDA GPU and tensor cores, and most importantly, the richness of AI software that runs on Jetson. Today, we're announcing that the Jetson Nano 2GB will be $59. Anyone can now build a robot. Developing robotic software is like all AI. A large computer like DGX writes the software, and a small computer like Jetson runs the software. The AI researchers at NVIDIA have trained many models using our DGX SuperPod infrastructure, and those pre-trained models are available on NGC. Using NVIDIA Transfer Learning Tool, you can adapt them to your domain. But how do we collect the vast diversity of objects, surroundings, and conditions data to train Isaac? And how do we validate Isaac's functionality in the infinite variability of environments and scenarios that it will operate? This is where the Isaac simulation comes in. Isaac Sim is built on Omniverse. It is a realistic world where we design and train robots. Isaac Sim imports files using USD Universal Scene Description and URDF Unified Robot Description format that describe robot models, sensors, and scenes. This simulation is from the work we're doing with BMW to create a platform to design, simulate, and operate a factory of the future. The robots are running the actual Isaac stack and interacting with a real-time simulation of the factory and other agents. This next example is the NVIDIA Drive Autonomous Vehicle System. Again, the starting point of AI is the DGX training system. This supercomputer learns from data and trains the AI. The AI software is then OTA'd into the car, powered by the NVIDIA Drive AV computer. Before road testing, our engineers simulate a virtual car in Drive Sim, built on Omniverse. The realism of Omniverse reduces the sim-to-real gap and allow our engineers to iterate rapidly, as if they can instantly update a test car to try their new software build. Let's take a look.
Hey Mercedes, please pick me up. Hey Mercedes, please take me for a ride.
Okay, let's start autopilot.
Hey Mercedes, please park the car.
Okay, I will go ahead and park the car.
This is work that we're doing for our Mercedes partnership. Starting with 2024, the entire fleet will be powered by NVIDIA Drive AV. On the left is the RTX server that generates the world view for each sensor. On the right is the Drive AV computer. The two are connected. The world views in Drive Sim are sent to the Drive AV computer, which perceives, localizes, plans, and actuates the virtual car in Drive Sim. This in turn generates new views of the world. Drive AV is running the actual self-driving car stack, all of it, and in theory has no clue it is in a virtual world. Someday, neither the AI or us will be able to tell whether we're in the virtual or physical world. Drive Sim is an open platform with plugins for excellent third-party engines. This GTC, you could see how AI will revolutionize computing everywhere, from scientific computing, cloud, enterprise data centers, edge, to autonomous machines. A few weeks ago, we announced our intention to acquire ARM. ARM is the most popular CPU in the world. Together, we can offer NVIDIA accelerated and AI computing technologies to the ARM ecosystem, reaching computers everywhere. Last year, we announced porting CUDA in our scientific computing stack to ARM. The performance was excellent and the response from the HPC community was fantastic. Today, we're announcing a major initiative to advance the ARM platform. We're making investments across 3 dimensions. First, we're complementing ARM partners with GPU, networking, storage, and securities technologies to create complete accelerated platforms. Second, we're working with ARM partners to create platforms for HPC, cloud, edge, and PC. This requires chips, systems, and system software. And third, we are porting the NVIDIA AI and NVIDIA RTX engines to ARM. Today, these capabilities are available only on x86. With this initiative, ARM platforms will also be leading edge at accelerated and AI computing. Let me summarize some of our announcements at this GTC. First, the age of AI has begun, and NVIDIA is in full throttle to advance this new form of computing. DGX SuperPod is a ready-made AI infrastructure for your AI researchers to become instantly productive. NVIDIA Clara Discovery is a suite of accelerated and AI tools for medical researchers. NVIDIA AI Inference Compute is growing 10 times every couple of years, and this year surpassed total CPU compute in the cloud. Hundreds of companies are operating services with NVIDIA AI inference, including Microsoft Office, American Express, and Tencent. NVIDIA Jarvis Conversational AI is in open beta. NVIDIA Conversational AI is twice as responsive, 1/3 the cost, and more natural sounding than running on CPUs. NVIDIA's Merlin Recommender is also in open beta, and we demonstrated NVIDIA Maxine, an AI video platform for services like AI video calls. Second, data center is the new unit of computing. We announced the BlueField-2 DPU, a programmable data center infrastructure on a chip. Doka with CUDA is the programming architecture. We announced a major partnership with VMware, the industry-leading data center OS platform. We're porting VMware to BlueField. Someday, 30 to 40 million enterprise servers around the world will be accelerated by DPUs. BlueField has an exciting roadmap. Over the next couple of years, we will increase throughput nearly 1,000-fold. Third, we're taking AI and data analytics to the world's enterprise. We announced a second partnership with VMware to enable VMware virtualization for the 3 computing domains needed for enterprise AI: virtualized, scale-out, and container microservices. And we announced that Cloudera is accelerating with NVIDIA AI. VMware and Cloudera serve nearly every major enterprise in the world. Fourth, NVIDIA EGX and our network of partners are helping the world's largest industries create and operationalize AI services. It is exciting to see successful EGX trials in manufacturing, logistics, retail, and healthcare. And finally, for autonomous machines, we've created the AI system to write the software and the robotics computer to run it. And with NVIDIA Omniverse, we have a physically based simulation engine to create the worlds to train the robots. The age of AI is in full throttle. Thanks for joining us today at GTC.